Hello, everyone. Thank you for attending this webinar. My name is Edwin van Dijk, your host of today, and I'd like to thank you for attending this webinar. Not everybody is signed in yet, but we will do the introduction anyway. This webinar is a joint effort of Software AG and TrendMiner. TrendMiner is a Belgian company focused on self-service analytics and was acquired mid last year by Software AG to expand their IoT and analytics offering. Goal of their acquisition is to bring advanced analytics faster into the hands of the many business users. With TrendMiner, we will focus on business users within the production operation of process manufacturing companies. Our presenter of today is Jeroen de Wolf. Jeroen is Strategic Account Manager for TrendMiner within Software AG, and he joined the company in 2014. His drive is to add more business value through analytics solutions to the operations of his customers by showing how self-service advanced analytics can help to achieve operational excellence, which in fact is the main topic of today's webinar. Jeroen will introduce himself in a bit more detail, and at the end of the webinar, he will answer your questions. During the webinar, we will have 2 poll questions, and we kindly ask you to participate, as we will directly show the results, and it will help us understand what you find important for us to focus on in the rest of the webinar. But before we begin, a little bit of housekeeping. I want to let you know that everybody is in a listen-only mode. Please make note of any questions you have during the webinar as we go along, and you can type your questions in the GoToWebinar question box. At the end of the presentation, we will go over the questions entered, and we'll read them out loud for Jeroen to answer them. If for any reason your question will not be answered during the webinar, we will send you the answer in a personal email afterwards. Additionally, all those attending today will receive a thank you email from us later this week with a link to the recorded version of this webinar. In the meantime, specifically for you as an attendee, you can download the PDF version of today's presentation in the handout section of GoToWebinar, and we also included some additional handouts which might be of interest to you. So with that, Jeroen, you can start whenever you are ready.
Okay, thank you, Edwin, for the introduction. Just quickly recap about myself. So indeed, my name is Jeroen de Wolf. I'm working for TrendMiner since 2014 as an account manager in Belgium and in France, basically in Europe. I also manage some of our strategic accounts. And due to my background as a chemical engineer, I'm also often involved in pre-sales activities where I provide more additional insights in how TrendMiner can be applied as a solution for our customers. Also, in my name, thank you for joining this webinar. To our listeners in Europe, good afternoon. To our listeners in the US, good morning. And I hope that you enjoy this webinar. Okay. So first of all, what do we see as common challenges in the chemical industry, right? TrendMiner is a solution that is typically tailored for the chemical industry, so I think it's good to focus a little bit on the challenges that we see over there. We see that the processes and the production process in general just generates huge amounts of data. And the challenge is then how to leverage that amount of data and how to combine it with the knowledge that lives in the minds of the people that are working on the production plant, that are working on the site. That's one of the challenges that we see. Another challenge is that, first of all, you have a lot of data on the other hand, on one hand, and on the other hand, there's a lot of people that have what we call process knowledge, but those people are typically not data scientists. That leads us with a technology gap in the sense that in order to analyze data, you need to have maybe some kind of a data science background. That's what you might think as a first place. However, the people who have process knowledge typically are not data scientists. So analyzing data versus process knowledge is also a challenge that we encounter often in process industry. And then next to that, all of the production plants have their own challenges, and those challenges can be related to improving quality, in reducing costs, whether it's maintenance costs or operational costs. Maybe you want to improve your reliability if you are in a very stable business and you want to keep your processes running as reliable as possible and you want to avoid downtime as much as possible. Maybe you have had some safety issues and you have a lot of projects that are focusing around safety. Maybe there's big challenges also for you. Well, anyways, all of those companies, all of the plants in production industry, they have safety targets that they want to meet, and safety is typically the primary thing. Apart from that, we also see a lot of projects going on energy savings, on reducing carbon footprint. We only have one Earth, right? So we need to take care of them and need to take care of it. And then, of course, some of them also are very much focused on improving capacity. However, without doing too much of investments. Okay, so there's improvement potential on all of these plants. That's what we are aware of. How to get to those improvements and get to those improvements faster, there's where the money is, right? If you have an issue today in your production plant and you're able to come up with a solution tomorrow or even the same day, then that typically will generate more value than if you have that same issue and you can only come up with a solution, let's say within half a week. So in terms of analyzing data, that means that the faster you can analyze your data, the faster that you can process your data, the faster you can get value from your data. Okay, it's a cliche, but indeed time is money in the industry that we are active in. Okay, as I asked you, or as I told you, there's a number of challenges that we see in the process industry. Most of you are probably working in one of these companies, so could I maybe ask you to answer the poll question that you will now be presented to you by our colleague. Okay, it's very nice to see that there's already a lot of you are answering the question. That's very nice. It is remarkable to see indeed that there is a huge proportion, I would say 1/3 of you says that they want to solve unsolved process questions. That's very nice because that's something that we will really address in the upcoming part of this webinar. Reducing costs and waste seems to be a very common challenge as well, and the other ones are more or less distributed equally. So I would say that 60% of you dives or indicates that reducing costs and waste or solving unsolved process questions thinks is the most important challenge that they have, whereas the remaining 30% or 40% is distributed equally between improving product quality, increasing production yield, and reducing energy consumption.
Jeroen, we will show the results now. So I close the poll and show the results to the audience.
Okay.
There we go.
Okay. So yeah, I already mentioned it while you were voting, but indeed the main challenges that were selected by you guys is reducing costs and waste and solving unsolved process questions, which is actually both of them will be addressed in the upcoming part of the webinar, and indeed the other three were distributed more or less equally: improving product quality, increasing product production yield, and reducing energy consumption. Okay, thank you for your answers. So let's proceed into the actual presentation. So we all agree that we need more business insights from data, right? At least if you're going to a conference, you'll see Industry 4.0 popping up everywhere. You'll see predictive maintenance popping up everywhere. And well, we all agree that those should come from insights from data. Now, what we see with a huge number of companies is that a first and most and maybe even logical choice is by thinking, hey, we have huge amounts of data. Why don't we focus on hiring data scientists? They are smart people who are aware of analyzing data, who can analyze data very nicely, and they will be able to provide us with the information that is in data, turn the data into value for us. Okay, now we encounter another challenge. Now, first of all, we see that there's just simply not enough data scientists out there. And even if you are able to find those data scientists, they can typically have challenges in interpretation of the outcome of a data science project, because what we see is that data scientists typically have a mathematics background or a statistics background, but they're not engineers. So if you are working on data that is related to a production process and you want to draw conclusions from a data science, from the outcome of a data science project, you typically need to have knowledge on that production process in order to interpret or in order to do good interpretation of the outcome of those data science projects. And that's a challenge that we see with many data scientists, right? The only people who can do the actual interpretation of the outcome of a data science project is probably a process engineer or a maintenance engineer or a mechanical engineer. And that's why we at TrendMiner believe that we should focus on empowering everybody else. And that is, by the way, what we mean with democratizing advanced analytics. Okay, diving a little bit deeper into that democratization of advanced analytics and the situation that we now see at many of our customers, or at least that we've seen with many of our customers. Let's first talk a little bit about what is analytics and what does it mean? What is it actually that you're going to democratize? If you're looking at analytics, there's basically 4 kinds of analytics that Gartner describes. First of all, we start off with what we call descriptive analytics. In descriptive analytics, you're going to use your data in order to describe what you're seeing or in order to describe what is happening. For instance, you are looking at the temperature and the pressure of a certain type of asset of your plant, and you are looking at the data and looking how it behaves. That's what we mean with descriptive analytics. You're literally describing what you see. The next thing is a little bit more advanced, a little bit more complex, is where you're going to use your data in order to diagnose what is going or what is happening and why did it happen, is the primary question that you're going to answer with diagnostics. Think of it as a doctor that is diagnosing a certain patient is going to ask questions. Where have you pain? And trying to find out why it actually happened. Okay, so for instance, in process industry, that means that you will go and find out what other parameters were behaving strange when you had your column trip, stuff like that. Okay, next thing that you will do once you have insights in with coming out of your diagnostics activities, you'll use your data, or you'll try to use your data to overcome certain things and certain undesirable events. And the first thing that you will do is you will try and predict the behavior of your production process. The primary question that you'll answer in that is, what will happen? And typically how we see that approach happening is by building some kind of a model that represents the behavior of your production process, and well, it tries to answer the question, what will happen? A little bit more complex is prescriptive analytics. Prescriptive analytics adds to that. Once you have predicted what will happen, you might want to advise maybe operators with a suggestion in order to overcome those undesirable events, right? And that's the most complex form of analytics that we know today. It's providing advice and what to do in order to prevent stuff from happening. Looking at the user persona, who do those kind of analytics today. On the left side of the screen, where we have descriptive and diagnostic analytics, typically we see those activities happening with engineers and operators, right? They are looking at data, and once there is an issue in the production process, it's typically the engineers who are going to dive into data and try and find out why those stuff were happening. Okay. On the other hand, we have predictive and prescriptive analytics. Is typically we see something with data scientists. They are building models and trying to mimic the behavior of the process with a mathematical model, trying to predict what will happen, trying to replicate the behavior of the production process in a mathematical model, and trying to see if they can predict those things, those undesirable things from happening earlier, and then providing a solution or providing advice to an operator as a prescriptive action in order what to do in order to overcome. Okay. The tools that they are using for that are typically data science tools such as Python, R, and MATLAB. Okay. Whereas on the other hand, we see the tools that are in use with engineers and operators. It's typically trends. So visualizing data in a trend, looking at how the temperature, the pressure was behaving. And for diagnostics, we are seeing that the primary tool in use for that is today it is Excel. Once you want to analyze something, you're taking typically production data out of a system like an historian, transfer it into Excel, and trying to figure out why stuff was happening, and do that in Excel. Now, this is a bit of an inconvenience. At least that's what we hear from our customers, right? And another inconvenience is that as soon as you have your insights, and you want to leverage those insights into more advanced predictive and prescriptive solutions, typically you'll see that the communication between engineers and operators and data scientists either goes through email, because those teams are typically even separated. Data scientists can be in the headquarters, whereas engineers and operators are on the plant. So the communication channel that we see between those two groups of people is also a challenge. And we believe at TrendMiner that we can improve this situation. So first of all, the message is they can all keep using their preferred tools, or their tools that they're currently using. But what if we try to put a platform in between that both of these user groups can use? The platform is of course called TrendMiner, and that has the purpose, first of all, to enable your engineers with more analytics capabilities, and I will show you in a minute how we do that. And also, that same platform can be used to contextualize your raw data, and that will then enable your data scientists, because what we see is the main challenge of data scientists is not so much the data science part, but it is the pre-processing of the data, making sure they have the correct data that in use for their modeling purposes. And because they typically do not have the process knowledge, for them the challenge is to make sure that they are using a good data set. And also TrendMiner, by contextualizing the raw data, helps data scientists to do their activities better. Okay, now what is TrendMiner? TrendMiner is basically one platform that consists of a number of visualization, I would say clients, visualization options, or you have multiple ways of visualizing the data, of working with the data. And the first way of working with the data is through dashboards, right? And Dash Hub is a hub within TrendMiner that allows you to visualize your data, to visualize your KPIs. It's primarily used by managers and operators because it provides a very easy and user-friendly, intuitive interface for basic visualization. As soon as you go to really analyzing the data and doing more with the data that you have today, is you're going to enter Trend Hub, and Trend Hub provides basically three kinds of activities. First of all, it allows you to analyze the past, so the data that you have in your historian, for instance. Then often where you will gather your insights and so on. After you have been analyzing the past and you came to insights, TrendMiner provides ways of monitoring the now. So that means you can create what we call fingerprints. I will show this in the demo. You can create fingerprints, and those fingerprints will then alert you, or TrendMiner will then alert you when these fingerprints appear. And a third way, or a third activity that you can do in Trend Hub is predictive, where you will use your historical data in order to predict what is going to happen. Now, what is important to remember or to highlight with Trend Hub is that all of these activities are based on pattern recognition and not so much on mathematical modeling. And this makes it an easy to use platform for non-data scientists in an environment that they are used to, hence a trend client, because if you remember the previous slides, the activities that engineers and operators do today is visualizing their data in a form of trends and analyzing in Excel. And we built on that visualization part and doing more with data on that visualization part. Now, I also talked how do we bridge the gap between people that have process knowledge and data scientists is by contextualization. So also to cover that part, we provide a platform or a piece of TrendMiner that we call Context Hub. And Context Hub, indeed, as I told you, allows to contextualize raw data and increases the interpretability of that raw data. For instance, you can add maintenance information on there. You can have shift handovers on there. You can have the LIMS, so lab data on there. Again, that will all become clear in the demo. And I guess it's time now to jump into the demo. And for the demo, I will do two things. First of all, I will show you how to use Trend Hub and how to use Analyze, Monitor, and Predict in Trend Hub. And after that, I will show you a demo how Dash Hub and how Context Hub can add value also to that. So if you are ready, let's jump into TrendMiner and let's go through some demo scenarios. Okay, so I now logged into TrendMiner, and what you see is, first of all, TrendMiner is a web application. So you deploy TrendMiner as a virtual machine and you connect it to your data source, which is typically an historian that contains your time series data. And once you have deployed TrendMiner, you can connect to TrendMiner through a browser, which in this case is Chrome, and you can start doing your data analysis. Now, either you can load your tags by just searching on a tag like temperature, then it will autocomplete based on tag name, for instance, or on description. I made a typo, temperature. It will complete on tag name and on tag description, for instance. You need to find one. Well, it's not in there, but it will also complete on that one as well. But for the case that I want to show you, I want to start on some work that I've been doing before, and I saved that work in as I would say a file, or we call it share as a view, and I will continue on that. Okay, so by loading this view, I'm actually loading a couple of tags from my historian, and I'm able to work with that. And the first thing that I want to do is, before I even go dive into problem solving, is to clean my data. The actual case that I want to solve is I have an issue in my temperature of my reactor, and I want to get additional insights into why I had this issue in my reactor, what other parameters were behaving strange. Maybe I'm able to find a root cause, and I also want to then also create monitoring and even predictive capabilities after I get my insights. But even before I go into analyzing the behavior of that reactor, I want to know that the data that I'll be using for my analysis is the proper data. And for that, I want to search on normal behavior. And in my case, normal behavior is when this blue line, this blue tag that I have is flat. So what I will do is I will search for that stable behavior of the blue one, where it is below 0.3 and where it is above 0.2. And let's say that I want stable conditions, so these conditions must be valid for 2 days. I click search, and within a split second, TrendMiner has been able to search through the whole history of that blue tag, and it shows me my results as a list on the right side, on the left side of my screen chronologically, and it also shows me where I can find those results in my historical overview on the bottom of my screen, marked as gray-blue areas in my history. Now what I want to do is I want to say to TrendMiner, I want to keep my results and I want to filter out everything else. And what the TrendMiner does, it filters out everything that is not compliant to these conditions, and these conditions, I have selected them as an engineer because I know that my feed stream should be between 0.3 and 0.2. And that's normal behavior. Now what I will do is I will dive into the actual issue that I want to solve, and that's going to be an issue in the temperature of my reactor. The issue that I'm having was at the 1st of May at 9:20 in the morning, 9:20 in the morning, and I'm not longer visualizing the 4 months, but let's say that I'm now visualizing 1 hour. And here you can clearly see the issue that I'm referring to. So again, in the previous step, we filtered out all of our not normal behavior, but what we see now is that even though we are in normal behavior, we see strange behavior in the temperature of the reactor, namely this temperature spike. Now that's something that I want to solve as a process engineer. The manager asks me to, hey, where does it come from? Why did it happen? We want to prevent this from happening again because it might have an influence on, for instance, the quality of our end product that we are making. Okay, in order to do so, first of all, I might be interested as a process engineer to know if this is the first time that we had this issue, or maybe we missed it already a couple of times. So what I will do is I will go and find similar situations in the past. How I do that today, if I don't have TrendMiner, is I will literally scroll back in time to see whether or not I have had this situation in the past. And this is a huge and cumbersome task for an engineer to do, but that is what we actually see today happening. So we believe at TrendMiner that we can make this more efficient, that we can improve this better for the engineer by providing, again, pattern recognition. That's what I mentioned in the slides. Pattern recognition technology that will search for the behavior that I have on my screen in the past. If I click similar situations, TrendMiner again will list me with the results. And in this case, it finds 21 results that TrendMiner thinks are similar to the behavior that I have on my screen, lists a result on the left side of the screen, and again indicates in the bottom where I can find those back in my historical overview. Now, what I want to do is I want to pull a couple on top of them. So what I will do is I'm selecting a number of these situations, putting them on top for visual comparisons. So now I'm indeed looking at 4 situations that clearly show stable behavior of my reactor, and all of those 4 situations clearly show that signature spike that I'm actually looking for. So now that I have not only 1 situation, but I have 4 situations, I can draw conclusions on further analysis based on 4 situations instead of 1, so that will make my analysis more reliable. Okay, and next thing that I want to do as an engineer is I want to solve this question, okay, where did it come from? What I will do now is I will go to my PNID and I will look at, okay, I'm looking at my reactor, what other sensors are surrounding that reactor, and I will have a look manually at my reactor. So that's again what we see happening at our customers before they are using TrendMiner. So they might check the stripper temperature, and they want to know maybe if there's something wrong. But apparently, if we click the stripper pressure, no, there's not really something to see. If we check maybe the stripper pressure, no, also not really something to see in the stripper pressure. And you must know, or you probably all know, that most of our customers have somewhere between 5,000 and 50,000 of sensors in their production process, so it cannot be they check them all manually, and by that we have come up with technology that we call Recommender Engine, and Recommender Engine will analyze all of the data that you have in your historian, and it will go search for interesting behavior that might be correlated to the behavior that you have on your screen. So for instance, TrendMiner recommends me to have a look at the reactor cooling water flow. If I pull on that one, I can see indeed why TrendMiner recommends me to have a look, because apparently when the reactor temperature is stable, also my cooling water flow, also the behavior of my cooling water flow is stable. And as soon as I have this spike, apparently there was an increase in cooling water flow. Now, this is a recommendation. My apologies. This is a recommendation by TrendMiner. And now I'm going to use my engineering knowledge to validate whether or not this makes sense. I'm looking at the temperature of my reactor, and the suggestion of TrendMiner was the cooling water flow. Now, if the temperature increases, I can indeed assume that my control system will try to cover or try to mitigate that increase of the reactor temperature by increasing the flow of the cooling water. So I've been using my engineering knowledge, my process knowledge, to validate that it is indeed a correlated event and that it is indeed correlated behavior. However, it's probably more a consequence rather than a root cause. So I keep using my recommender engine, and what you see is still trying to explain the reactor behavior. What you see is that some of the recommendations in TrendMiner have this early indicator label. That means that TrendMiner has seen something significantly upstream of the event that you're trying to analyze, and that thinks or it makes a suggestion to have a look at the behavior of the cooling water outlet temperature now, because indeed it sees more or less 10 minutes before the event in the reactor, it sees this spike in the cooling water outlet flow. Now indeed I can again use my engineering knowledge to validate whether or not it makes sense. Assume for this moment that this is indeed the root cause of the disturbance in the reactor, and that I want to keep working on that cooling water outlet temperature. Okay, now as an engineer, I have two options. Either I'm able to control the cooling water outlet temperature, and I am able to take away the spike that probably initiates in 10 minutes an increase in my reactor temperature, and then I've solved my problem, so then I will no longer have that temperature spike. Or maybe it's a parameter I cannot control, and then the best thing I can do is I can monitor for this behavior, and when I see this behavior happening again, at least I know that I have a 10-minute time frame to overcome or to take some actions to overcome that spike in my reactor temperature. And this is the event that I actually want to prevent. Now, to clean up my screen, I'm going to remove this event in this one of these events, which was where the cooling water outlet temperature was at another level. And now I have three situations that clearly show stable behavior of the cooling water outlet temperature, and then this significant spike, signature spike, that indicates an upcoming disturbance in my reactor. Now I want to detect that, and in order to do so, I'm going to create a fingerprint. And a fingerprint is not a mathematical model, it's just filling in the area in between all of my events. And by that, it can then do pattern matching on that cooling water outlet temperature. And as soon as it detects something that is similar to this kind of behavior in this cooling water outlet temperature, I can trigger an action. But first I need to save this fingerprint, so I'm creating this one, and then I can go to my monitoring window where I can actually choose the options that I have after TrendMiner detects a match. I can first of all toggle it on so that I'm enabling monitoring, and then I have a trigger, so I want to detect a match, and then as soon as you detect the match, I have an action that is triggered. First of all, I want to create an inbox notification, which is what I see here. It will then, as soon as it detects, it will pop up with an annotation or in my inbox, in my in-application inbox. So that's inside TrendMiner. Second of all, I can have TrendMiner send an email, for instance, to my operator at company.com, that says expect an increase in temperature in the reactor. And I can even say start pre-cooling now. So by doing that, I'm actually providing him with advice that he can now do in order to overcome the event in the reactor. And I can also create a context item in order to populate or to capture all of these events for reporting afterwards. I will show you in Dash Hub and in Context Hub what you can do with those context items. But going back to my presentation, I'm going to, going back to my presentation, where I have talked to you about the different kinds of different kinds of analytics, descriptive, diagnostic, predictive, and prescriptive. Looking back at the demo scenario, we have been doing descriptive analytics because we have been analyzing the data. We have been analyzing the data, we have been looking at data. What happened, right? We started with that temperature spike. Why did it happen? Recommender engine helped us with diagnosing the problem. We have used also similarity search in order to recover a number of events in the past. We have used recommender engine to find correlated events, hence the increase of the cooling water flow. And we've even been able to detect the root cause of the event. Predictive, because we've created a monitor that will alert us 10 minutes on that blue tag, if you remember, because that will alert us 10 minutes up front that we have an upcoming disturbance in the reactor temperature upcoming. And we've been doing prescriptive by sending an email to the operator that he should start pre-cooling the reactor up front in order to mitigate the effect in the reactor. And we've been all doing that without having to write a single line of code, without having to program any kind of algorithm. We've just have been using a trend client with a very strong analytics backend. And that is basically what TrendMiner, or at least TrendHub, is all about. And now I told you before I started with the demo that I will also dive into Context Hub and into Dash Hub, and to show you how those can provide added value. And this is now the second part of the demo. So for that, I will jump into another demo screen. 1 second for that, where I will show you an example from a customer who makes batches, right? And what you see now is I jumped into Dash Hub, and Dash Hub provides you with a way of visualizing a number of very simple trends, I would say, that give you a very clear overview of a certain behavior, certain number of trends that you want to follow up, and also provides you with the capability to visualize KPIs, visualize events, and so on. The case that we are discussing here is where we have been producing in the last 4 weeks 32 batches. One batch looks like this. So we're following up a number of parameters. I think it's 5 parameters, 5 sensor values. Of those 32 batches, 3 were out of spec pharma, 9 were in spec pharma, 23 were non-pharma batches, and 14 of them were ideal batches. Now this gives me a very good overview. And this can be used either for an operator maybe, or even for a manager in order to follow up on the production. Now again, I'm going to analyze a little bit, and particularly I'm interested in why I have those 3 off-spec batches. And for that, again, I'm jumping into TrendHub. So what I can do is I can visualize the behavior of my batch in TrendHub by clicking the icon in the top of the tile, and then it will open up the batch in TrendHub. What I can also do is I can dive into all of my individual batches, into all of my individual events in Context Hub, which I will do by clicking again this icon in the top of the tile, and then I will open up Context Hub. And Context Hub is basically collecting events either from manual entry or from an entry from another system, like an ERP system, a LIN system, an OEE system. But basically, it feeds alternative non-time series data into TrendMiner that you can then use for interpretation, such as this quality that we now want to analyze of our batches. Okay, now that we are visualizing that one batch, so we can do that in TrendHub and see how one batch should behave. Okay, so this is the behavior that we are expecting. Now what we can do is we can use the information that we have in Context Hub to visualize, for instance, our bad batches. For that, we go again to search, and we can go and find for context items. And context items then takes us to our work organizer, and we can say, hey, we are interested in those ones that had low viscosity. Those were the ones that were non-pharma related. Okay, so I'm going to search for context items, and I can indeed retrieve those 3 batches that I had here also listed in my Dash Hub, and those that I also had listed in my Context Hub. Those are now popping up in my Trend Hub. I can visualize them, and I can put them on top of each other, and I can, if I want, I can also visualize those parameters that I had of my original batch that I looked at on how to see. And apparently, at first sight, it doesn't really show me anything that looks very strange. So by just looking at the behavior of those 3 batches, I cannot really conclude what's wrong or what's strange about it. Now what I will do is I will use again, I will first of all clean off my screen, and I will use my ideal batches in order to make a better comparison between my ideal batches and the ones that were out of spec pharma, because if I'm visually comparing them one with another, maybe I can retrieve more information on that. So I will use again my search, and I will not search for my low viscosity batches, but I will search for my ideal viscosity batches. I'm going to search, and now I'm retrieving 14 of those good batches, good behavior, and I will visualize a couple of them. So I will take this first one and I will add, I would say, 3 on top of them in order to then again make a fingerprint. Remember the previous demo where we used a fingerprint in order to detect a spike? Now we can do the same to not really detect behavior of batches, but to see how good behavior of our batch should look. I'm adding a couple of those tags, so those 5 tags that I'm interested in, and I am again creating this fingerprint. And I will create this fingerprint as in fingerprint for good batch. Okay, I'm going to save this one, and now I can go back and retrieve my bad batches. Go to my context items, again very easily retrieve the ones that had low viscosity, search for them, take them on top of each other again visualize those other valuable parameters, and now I can take my fingerprint and put my fingerprint on top to see really how it compares to my bad batches. And now I can start seeing some interesting things, because although at first sight my non-pharma batches, the one with low viscosity, had good behavior, by literally comparing them with the ones that were pharma grade related, I can really see some deviation in this reddish brown tag, where apparently the ones that were out of spec didn't go as low as the ones that I used to create my fingerprint, so the behavior that I should know. So again, I can use my process knowledge to then say whether or not this could be the actual root cause of the behavior of the bad batches. And now I've been using, first of all, Dash Hub to create an overview, a nice overview. I've been using Context Hub, where I collected all of the behavior that was coming from a LIMS system about good batches, bad batches, ideal viscosity, pharma batches, and so on. And I'm again been using TrendMiner in order to analyze the behavior and compare behavior and find differences and do root cause analysis. So that is how Dash Hub and Context Hub provide added value on top of Trend Hub and provide a good platform, a good solution as a whole. Okay, going back to my presentation, what I've shown you is the following. I've been showing you TrendMiner as a combination of Trend Hub, Context Hub, dashboards and notification, and even asset structure and mapping, which is something I skipped in this introduction video. But what is important to know is that TrendMiner is one platform. We license TrendMiner as one platform. you receive TrendMiner as one platform, and all of the modules, all of the hubs that you have seen are included in TrendMiner. To that platform, you can connect, first of all, relational data, typically to Context Hub, where you have your context feeding into your TrendMiner installation. And second of all, you can connect, of course, time series data, which will be the primary data source for your analyzing activities, monitoring activities, and predictive activities in Trend Hub. We support historians like the Pi server, AspenTech server, Honeywell PhD, but also IoT platforms such as our own Cumulosity platform, obviously. Okay, the primary user persona. We see that TrendMiner is primarily used by people who have domain expertise, but that are not data scientists. In essence, that is by default the process engineer, but it can also be a production engineer who's following up the production, or a maintenance engineer who is trying to find out triggers for predictive maintenance, trying to look at behavioral faults, for instance. And operational excellence teams also make use of TrendMiner when they are, for instance, comparing behavior of identical sites on multiple locations. You can also connect multiple historians of multiple locations to TrendMiner, so consolidating those data is also an asset that you have in TrendMiner. Now with with Context Hub and Dash Hub, we also see secondary users coming into place with TrendMiner. First of all, you have your control room operators, because you can create those dashboards that give a very nice overview of KPIs, production KPIs, and some basic trendings of a number of parameters. You could even do maybe fingerprints, monitors in Dash Hub. And operations managers, plant managers, site leaders are also now starting to use TrendMiner for instance, reporting capabilities, event collection, and also creating, for their purposes, other kinds of dashboards that again relate to maybe even corporate KPIs. So those are the user persona that we see of TrendMiner. The next poll question that I want to ask you is, what about your case? Who do you think in your organization would benefit most from TrendMiner? Okay, the results are coming in. Indeed, more than half of you has indicated that they see most value for process engineers. Also a huge portion for the operational excellence team, and also a number of people who also see value for managers. So that's good. Maybe Edwin, you can finalize the poll so that we can now visualize the results. So indeed, most of you think indeed that process engineers are the main users, which is indeed true. However, operational excellence team can indeed also be a main user of TrendMiner. Okay, so thank you for your votings. Indeed, process engineers is apparently the most selected option, which is also what we see with our customers. Now, who are those customers? We have a customer still in chemical industry, but not exclusively, obviously. We see also similar activities in related industries such as oil and gas, metals and mining, energies and utilities, food and beverage, and pharma. Hopefully you're able to relate your activities to some of these logos that you have on the screen, and that means that maybe TrendMiner will also be relevant for your case. If so, feel free to reach out to us after the webinar. We'll do some follow-up, as Edwin has also told, so we will reach out to you as well ourselves. But anyways, if you feel that there might be value in TrendMiner for your case, let's stay in contact. To emphasize maybe on the benefits, so those customers, what do they get in terms of benefits from TrendMiner? In terms of, I would say, more general benefits, we see an increase of employee efficiency because you're enabling your engineers to do data science-like activities with TrendMiners, but you're enabling them on a more efficient way. They can do it better, they can do it faster, they can do more projects. So that's the upper right one, the upper left one. if you're making your employees more effective, more efficient in their activities and analyzing data, you'll see that they'll be solving more unsolved use cases. You're addressing more opportunities that they can address, more opportunities, more solved cases, the result in an increased revenue, increased profitability with our customers. By using the monitoring capabilities in TrendMiner and TrendHub, we see that it's also used to even avoid abnormal situations, such as the temperature spike that I have shown you. And with Context Hub and Dash Hub, you can even use TrendMiner to create a learning organization. In the middle, you have some more concrete examples of our customers. One was even able to, for instance, decrease the downtime of a certain unit with 50%, and they did a project with TrendMiner that again covered the whole analytics scope, so from descriptive diagnostic discovery all the way to creating monitoring and to do predictive. And that indeed resulted in 50% downtime reduction without the need of a data scientist. The one at the bottom is also maybe a very relevant one to mention. Is one of our customers looked at what kind of return they are estimating from TrendMiner, and they've been looking at the cases and the use cases that they have been tackling with TrendMiner, and they estimated the combined returns on something like $4 million of additional value created. So that's really some bold statements of that customer, and that's also the kinds of returns that we are aiming for, obviously. TrendMiner is now not longer TrendMiner as such, in the sense that we have been acquired by Software AG a little bit more than half a year ago. That means that we are now part of a bigger family, the family of Software AG. Within the value proposition of TrendMiner, it can be related to also empower data science capabilities in your organization. Software AG has other solutions tailored more towards the data science, such as Semantis and Apama. If you're not yet there in collecting data and you're looking, for instance, at IoT systems, then maybe Cumulosity can be a good solution for you to start collecting sensor data and start generating time series data that might be valuable for your business as well. So we have solutions both on the data science side and on the operations side. And the actual message that I want to come across is that it should be a cooperation between those two approaches, and that it's not one or the other, and that it should not be a separated thing, and that by applying the software AG philosophy, you are enabling all of them, basically. To wrap up, why TrendMiner? First of all, TrendMiner is self-service analytics, so that means that you're empowering your whole organization. It's easy to use, and it's a plug-and-play platform. In the platform, there's unique capabilities that are really tailored towards the use that we are seeing in process industry, for instance, the kind of activities that we see with process engineers, maintenance engineers, and production engineers. Technology that is based upon pattern recognition, not so much upon the traditional modeling approach. And a third of all, and I think is not unimportant to mention, is that we have a proven path to success. You've seen the customers that we are active in. We are working together with our customers, with our customer success team. Our customer success team really ensures that the usage of TrendMiner and the application of TrendMiner at your organization is as big of a success as it is with all of our other customers. They help you with the adoption of the software. They help you with training. They help you in showing you how to apply TrendMiner to your use cases. And with that, I actually want to thank you for your attention. If you have any questions, I'll be happy to follow up on them. Thank you so much.
Jeroen, thank you very much for this very nice presentation. So again, if you have questions, you can type them in the questions box from GoToWebinar. Some questions are already coming in. So the first question that actually came in from Fred is about TrendMiner licenses. So perhaps you can explain a little bit how it works. The question is TrendMiner available as a single or network license, or how does it work, and what are the costs?
Okay, first of all, thank you, Fred, for this question. How I understand the question is, can TrendMiner be installed as in the installation of TrendMiner can be on premises, where we provide you with a virtual machine, and you can then connect TrendMiner to your historian to analyze your data, or and there's no trend clients that no client applications that need to be installed, because you're then accessing TrendMiner through your web browser. Or you can have TrendMiner or Software AG host TrendMiner for you as a cloud solution, and then then you basically only have to make the connection between your historian or your data sources to TrendMiner, and you don't even have the issues of hosting the application yourself. I hope that this provides you with an answer, Fred. Next question.
Yeah, it's a pretty funny question. Actually, the poll results were based on how many votes. Well, there are quite some people in the room, but not everybody actually voted. So it was around 70 to 80% of all the registrants. So that is quite a good result. Another question that actually came in is how is the data made available within TrendMiner?
So the data is made available in TrendMiner. You deploy TrendMiner either on premises, or we host TrendMiner for you as a cloud solution. And then you can connect TrendMiner to, as a primary database, typically is going to be a time series database, so a historian, and that goes like that. That's the connection. And there's also multiple additional connections possible for Context Hub for the contextualization.
Okay, thank you. And a last question, because we are already out of time. We spoke about batch analytics in your examples, but one of our questions is we have a continuous production process, and can TrendMiner also handle that?
Yeah. Yes, of course, right? So TrendMiner can be used in multiple industry verticals, both batch production, continuous production. We have refineries as our customers. We have polymer plants as our customers. So yes, definitely.
All right, thank you so much, Jeroen. So with that, I would like to conclude the webinar. We thank you definitely for your participation in the webinar and in the poll questions and the questions you asked. But before you leave the webinar, we kindly ask you to fill in our short survey, and the survey will appear when you close the webinar session. So we appreciate your feedback that allows us to improve our next webinar. So I would like to thank you again for the webinar attendance, and I wish you a great remainder of your day. Thank you so much.
Okay, thank you.